do is gonna give it static.
Yeah. Okay, so thinking about this system, which variable do you guys want to cancel out? Y? I heard Y. That's what I would choose too. And I would choose Y because this one it's already negative, and the coefficient's 1 right now. So we only need to multiply this top equation by a number. We don't have to do anything to the bottom one. So to get our y's to be opposite, we multiply this one by 4. That'll give us 8x minus 4y equals 36. And then our bottom equation stays the same. 3x plus 4y equals negative 14. Okay? From here, add them together. 8x plus 3x, 11x, or negative 4y plus 4y. That cancels out. So our y is eliminated. So we have 11x equals 36 plus negative 14 is going to give us 22. So now we just divide both sides by 11. X equals 2. And then we can choose one of our top equations to substitute our x in. Which one do you guys want to choose? Which one looks easier? The top one, yeah. The coefficients are smaller. It's less negatives to deal with. So I'm going to substitute our x in. X is 2, so 2 times 2 minus y equals 9. So that becomes 4 minus y equals 9. And then I will subtract 4 from both sides. So you have negative y. Don't forget, we have to keep, if it's minus y, we have to keep the minus sign in front even when we subtract the 4, when we get the 4 on the other side. That negative sign still stays. It's attached to the y. So it's negative y equals 9 minus 4 is 5. And then to get our y to be positive, we divide both sides by negative 1. So y equals negative 5, which 2 times 2 is 4, minus negative 5 is 9. So we can always double check our work by plugging in our variables, right? And then we write our final answer as a k. Don't forget it. A solution of a system of equations is a point on a graph. These are two functions. We're seeing where they intersect. Okay? Any questions about this? Just wanted to keep this stuff. Yes, question.
So I read it wrong the first time, and I solved it.
Yeah.
So I had put 2x minus 9 equals y. I don't know why I read it backwards.
Okay.
I ended up getting the same answer.
2x minus.
Like I subbed in.
So you had 2x minus y equals y?
No, I had 2x minus 9 equals y.
Yeah.
And I subbed that in like after.
Yeah.
Y.
Well, I'll show you why that works. Because if you add y to both sides and you subtract 9 from both sides, that's what you get. So it's actually the same equation. So I guess you got a little lucky, but that's why that works. Well, cool. The more you know. Okay, any other questions about this? Just wanted to warm the brains up a little bit, keep the material from our quiz fresh, in case anyone's going to be That's just the kind of stuff that's going to have to stay fresh in our minds. It's not going to go away. Awesome. Okay, I'm going to erase all this. And then we're going to get into, you guys already have your books out, which is good. And we're on page 4, we're going to start on page 49. So we've got this table. We're looking at someone really likes bugs, and they are seeing how many fruit flies and how many fire ants they can have over the course of 4 weeks. I can't say that I would study fruit flies or fire ants, but you know, if that's your thing, go for it. Follow your dreams. So let's look at these fruit flies first. So week 0, that's our starting point. When we start, we have 20 fruit flies. And then after the first week, we have 40. Second week, we have 60, 80, 100. And so with our fruit flies, we have a constant that we are adding to our fruit flies. What's the constant that we keep adding each week? 20, yeah. So we add 20, add 20, add 20, add 20, add 20. Okay? So we are adding a constant each week to our fruit flies, and that constant is 20. And now let's take a look at the fire ants. So we start with 20, and then we get 40, and then we get 80, and then 160, and then 320. So what's happening to our number of fire ants each week? It's doubling, times 2, yeah. So our fire ants are doubling each week. And so instead of having a constant add-end is a word that's like a number that you add. So instead of having a constant add-end of 20, we have a constant multiplier, and that constant multiplier is 2. So we will write that in, just like we did with the fruit flies. Times 2, times 2, times 2, times 2, times 2. Okay. And then at the bottom here, let's switch back to our fruit flies. So if you're adding the same amount each time you increase your x, your weeks, increase the time, that sounds a lot like a linear function. Like if you have 3x plus 5, you start at 5 and you add 3 with each x, right? So this time we start at 20 and we're adding 20 each time. So I want you guys to take 30 seconds and answer number 2. Write out a linear function of how you can represent the fruit flies. 30 seconds. Okay, who wants to share their equation? I need a volunteer. So if we're writing a linear equation, a linear function, we know that we need an x, right? We have an x, and we need a slope, and we need a y-intercept, right? Y, it's like a y equals mx plus b. So y equals, so what would our slope be? 20, yep. So 20x plus, what would our y-intercept be? What's our starting point? 20. Good. 20x plus 20. That's how we can represent the growth of our fruit flies with an equation. So now, if we want to keep our fruit fly farm for 50 weeks, we'll know how many fruit flies we have at the end of that time. It's a lot of time to commit to fruit flies, but I don't know.
How do you count fruit flies?
Very carefully, I guess. I don't know. But if you want to try this at home, leave a bowl of fruit out on your counter. Just leave it out there for a few weeks. You'll see a lot of fruit flies. Please don't do that. It's disgusting. I accidentally did that in my apartment one time, and it was gross. I had to throw the whole bowl away. It was not okay. Okay. Does that linear function make sense to everyone? Any questions about how we built that linear function? Something we've seen before. If we were out on the graph, it would just be a nice straight line. Okay? All right, I'm going to clear this and then go down to number 3, which I think is the same page for you guys. Okay. Now we're going to take a look at our fire ants. Our fire ants, which we already said we're doubling, we're multiplying it by 2 every time. So our process of building a function to represent it's a little different. Instead of adding 20 each time, we have to multiply by 2 each time. So here we can see 0 weeks, we start at 20 fire ants. Week 1, we double it, 2 times 20, that gives us 40. Week 2, we double it again, so 2 times 2 times 20, 80. So week 3, we double it again, 2 times 2 times 2 times 20. I'm not writing the parentheses. You can write parentheses if you want. That might just help us kind of see that we're doubling what we had before, right? Because this part is this, and so on and so forth. Okay? So week 4, how many times? So week 4, we got to double it again. So 2 times 2 times 2 times 2 times 20. Yes?
I mean, you have how many 2s do you have?
A lot. Yeah. Well, I'm doing it this way just for.
No, I was saying, can I do it like this?
You can, yeah. I know. You'll see like what that sort of builds towards. I'm building towards. We're all going to the same place. Yeah. So we have a bunch of 2s, and then last one, X amount of weeks. That's an unknown amount. So I'm going to write it out as much as I can first, and then we're going to talk about an easier way to show it. So here's how I'm going to write it. I'm going to go 2 times 2 times 2, and then dot, dot, dot. And if you see 3 dots in math, that means it's kind of like a list going on for however long. Since we don't know what X is, we don't know how many 2s there are. Okay? So, and then times 2 times 20. And make a note that we are doing this X times. Okay? So for X weeks, we're multiplying 2 to our original 20 X number of times. Whatever our X is, that's how many times we multiply it by 2. So let's think, there's definitely an easier way to write that than with a whole bunch of 2s and with a bunch of dots. And it'll get confusing, it'll get messy. So So let's think about how we can write all those 2's. What's an easier way we can write those 2's? So if I want to write over on the side over here. So if I have 2 times 2 times 2, how can I rewrite that? Almost. Think about, just use 2's, don't use any other number. Like what? Did I hear someone say it? Exponent? Exponent. That's right. When we multiply a number by itself a certain number of times, it's an exponent. So 2 times 2 times 2 times 2 is the same as 2 to the 4th. Okay? So if we go back to our table, we're multiplying 2 times 2 times 2 times 2 x number of times. So what we can do is we have our 20 times 2 to the x power. Okay? So now, if we want to keep our fire ants for 10 weeks, we just do 20 times 2 to the 10 power. That would be a lot of fire ants. That would not feel good if they got loose. Okay, any questions about how we got that? Does that all make sense? How we built that? Awesome. Well, congratulations, you guys have just built your first exponential function. That's our new unit. So it's exciting, I guess. I don't know. So we're actually going to go back a little bit in our book, and we're going to talk about some definitions. But I wanted to use an example first and have you guys build. Get to the next slide. Okay, page 45. So we got some definitions in here for you guys to fill in. Exponential functions. Our standard form of exponential functions is y equals a times b to the x power. And a is what we're going to call our starting point. And what we're looking for to have a starting point is when x equals 0. Because if we have a times b to the 0, that's really messy, hang on. A times b to the 0. What's something to the 0 power? What's it? Yeah. What's it? It is a number. What's the number? 1? Yeah. So anything to the 0 power is 1. So if we have a times b to the 0 power, that equals a times 1, which equals a. That's why a is our starting. That's why we look for x equals 0 to find what our starting point is, find what our a is. Okay? So a is our starting point. B is our multiplier. That's the number we keep multiplying and multiplying on top of itself to find. So like in our last example, the starting point was 20 fire ants to start with, and our multiplier was 2 because we were doubling it every time. So we kept multiplying by another 2. And then the domain for an exponential function is all real numbers. You can use every real number from negative infinity to infinity. Those all work. There's nothing that is going to be undefined. And then our range is y is greater than or equal to k. And we'll talk about k later. There's an invisible k right here. But we won't be using stuff with k right now. So for the time being, it's going to be from 0 to infinity. But eventually we'll find one, so you add a little bit on the end, and it'll be from whatever that number is to infinity. And an exponential function has a horizontal asymptote. So I'll just sketch a little graph. They usually look something like this. And that goes on and on and on. Just as a quick little visualization to see what that means by that horizontal asymptote. Okay. Any questions about our definitions, our domain range? Is that all making sense? You see how that last example we did was expressed by that exponential function. We had our starting point, we had our multiplier, so on and so forth. Awesome. Okay, I'm going to go to the next one. Okay, so our first example, they give us a exponential function, and we have a table that we can fill out. So first thing that should jump out at us is x equals 0. So x equals 0, that means starting point. So what is our starting point in this function? So let's think about, so we have 2 and we have 3. Which one of these is A, which one of these is B? What's up? 2 is A, 3 is B. So which one of those is our starting point? A, yeah. So our starting point when x equals 0 is 2. And we can do a little bit of math down here, just so we remember where that comes from. 2 times 3 to the 0 power equals 2 times 1 equals 2. Okay? X equals 1. Move over a little bit. X equals 1. 2 times 3 to the 1 power. Anything to the first power is going to be itself. 2 times 3. That equals 6. Okay. Why don't you guys fill out the rest of this table? Might need to use a calculator for some of the bigger numbers. That's fine. But fill in the rest of this table. I'll give you guys a minute and a half, 2 minutes. So like this one's 2 times 3 to the second, and so on and so forth. All right, so take a couple minutes. Ask anyone any questions if you got some, but fill out the rest of that table. Okay, x equals 2, what did we get? Sorry? 18? Sounds right to me. And then 3? 54? And 4? Say that again. 162? Sounds right. Cool. And we'll also notice, I'm going to erase this work down here. And here's part of the reason why we would call 3 our multiplier, because to get from 2 to 6, we multiply by 3. 6 to 18 times 3. 18 times 3 is 54. 54 times 3 is 162. So that's where we see, keep tripling it, we keep multiplying it by 3, right? Okay. Next one. let's do this one real quick. Okay. So this time we are building a function with our table, with our completed table, like we did with the fire ants. So what's the first thing we should look for? The starting point, right? When x equals 0. So x equals 0 right there, and our function is 3. So 3 will be our starting point. It's 3 times something. So let's look from 3 to 18. What do we multiply 3 by to get 18? 6. And then, to be safe, you can double check with your calculator. 18 times 6 is going to be 108. Yeah, it's 108. So on and so forth. Okay? So what's our multiplier?
6.
Times 6. Yep. And then to the x power. So 3 times 6 to the x power. Okay? Everyone see how we built that? Give our starting point. See our multiplier. Multiplier has the exponent. Okay? And then this will probably be our last one. We only really have time for one more, so I'm going to make some more room. Get this one out of here. So we're on number 5, page 46. So same thing. We're still building a function with a table. This one's a little different because we don't have an x equals 0, right? It starts at 2. Our table starts at 2. So we got to think. We got to work with what we're given right now, okay? So we'll start at the 192. Go to the 48. What would we multiply 192? Let me skip ahead a little bit. Let's look at this 12. Yeah. Start with smaller numbers usually helps.
-4.
Not -4. 12 times -4 is going to be -48, right?
Yeah, but it's going down.
It is going down. So if you multiply, if you're multiplying numbers and they go down, it's like dividing, right? So we're really dividing. So 12 divided by what is 3? 4, yeah. And you can either write that as divided by 4, or, and this is really the better way to do it if we're going to build an exponential function, dividing by 4 is the same as multiplying by what?
0.25.
0.25, 1/4. So dividing by 4, or we could say multiply by 1/4. 1/4. So to get from 12 to 3, we multiply by 1/4. I'm usually going to use multiplying by fractions. That's definitely my preference. And we do have to think about it in terms of multiplication to do an exponential function. So 3 times 1/4 is 0.75. So we have our multiplier. I'm going to write the function below this line. So we have 1/4 to the x. Now we just need our starting point. So we have this x equals 2. We have this x is 2. And I'm going to write it down here. So we actually need to go back 2 steps for x equals 1 and x equals, not 2, oops. X equals 0. And that's what we want to get. So if we're looking at our table, and let's say we need to go back from 5 to 4. So if we work our way backwards in the table, what do we multiply our 3 by to get to 12? 4. So to work backwards in this one, we multiply by 4. We do the opposite of what our multiplier is. So in order to get from 2 to 0, what do we need to do? We have our 192. We work backwards. We say we multiply by 4, which is some big number. And then we do it one more time. And this is the number we want. So use your calculators real quick. Multiply 192 times 4. Say that again? 2017, okay? 3072, that makes more sense. So 3072? Or that's the last one, that's the last answer? Okay, cool.
Yeah, for when it's
Yes.
768.
Yeah, so 3072. So that's our starting point. 3072. Okay, I think that's the last one. Yeah, that's our last example. Any questions? This last one is a little tricky. We had to work backwards a little bit. But I want you guys to start seeing that when we going up with our x's, we work one way, and then we work in the opposite way to go down with our x's. Okay? So I think that's it for the teaching. I don't know if they have homework yet,
They
or
absolutely have homework.
yeah.
Homework every day.
Got about 10 minutes. Work on some homework. And
Yep. And we are still grading the test. The deadline to submit Unit 7 is Friday. So completing homework is essential to passing the class. So make sure you have that submitted. So take out your devices and start working on Unit 7.